大家好, distinguished guests, ladies and gentlemen, morning. Thanks of FISITA, it is my great honor to introduce Toyota's development of environmental technology today. About the question of Chen, here is my answer. We don't think HEV can resolve all subjects we are facing now. However, the HEV can resolve all the subjects. HEV technology can be utilized to the next generation technology, such as EV, PHEV, FCEV. So we think it is very important to develop HEV, and we have been developing it to resolve many subjects. Today, I will explain the detail later, including the roadmap on energy diversification. Today, I will cover 3 topics as shown here. Let us briefly look at the current situation surrounding automobiles. With the development of industry and technology since the 20th century, a massive amount of fossil fuels were consumed globally. Consequently, these subjects have been raised. Anxiety over future petroleum supplies, increasing CO2 emissions, and increasing air pollution. Here in China, there are the problems such as increase of gas price, the generation of PM 2.5, and the dependence of the oil. Therefore, oil saving and the alternative to oil are urgent subjects. Now, the development of various types of vehicles are ongoing all over the world. There are some kind of similarities now and even more than 100 years ago in searching various possibilities of vehicle energy. Next, I will explain today's environmental technologies, Toyota's environmental technology concept. For future society, Toyota have been working on energy conservation and fuel diversification. And we also believe that environmentally friendly cars can only contribute to the environment and the society through widespread use. So, we also consider how and in what manner those environmentally friendly cars should be spread into the society. This slide shows the diversification of automobile fuels and the powertrains. On the left side, the different types of primary energy sources. And in the middle, automobile fuels processed from those primary energy sources. And on the right, automobile powertrain using those different types of fuels. The technologies of alternative to oil have various subjects now. Therefore, the fossil fuel will have been the mainstream of the automobile energy for some more time. We consider the conventional vehicles and hybrid vehicles are the fundamental technology for powertrains even in the future. Speaking of fuel efficiency, we are going to utilize various technologies, and we have been aiming at improving global average fuel consumption of Toyota vehicles by 25% in 2015 compared to that of 2005. Next, I explain our efforts of fundamental technology on conventional vehicles. This slide is regarding the gasoline engine improvement. As a technologies to improve the thermal efficiency of the engine, we consider Atkinson cycle, direct injection, cooled EGR, reducing mechanical loss, and downsizing with turbocharging are effective. The light diagrams show the thermal efficiency improvement by adapting Atkinson cycle to the conventional vehicle engine. We will use these technology for conventional vehicles as well as hybrid vehicles. This slide is regarding the improvement of drivetrain. Toyota considers that CVT is appropriate for small and medium engines, and for the mid to large engines, multi-gear automatic transmission is appropriate. We aim at maximizing the fuel efficiency and driving performance by the latest multi-gear automatic transmission and CVT technology. The CVT and multi-gear AT contribute to improve the power transfer efficiency. That is because these transmissions enable to utilize the engine's high thermal efficient area. On right side, the thermal efficiency of engine with each transmission installed on the same engine. You can see that in order of CVT, 6-speed AT, 5-speed AT can use more efficient region of engine. This is regarding the latest CVT technology. We have developed the so-called Super CVTi. The transfer efficiency of this CVT is the world's highest level, and it realizes both fuel efficiency and driving performance in high levels by advanced total management system. We will wait for your coming to see this CVT in our display booth. This CVT is going to start to produce in 2014 here in China. Next, I explain HEV. We think hybrid technology is core technology for sustainable mobility. The HEV has characteristics shown in this slide. No need to external charge, and no need of charge infrastructures, long drive range, minimum battery, clean emission. From these characteristics, hybrid vehicle would play a main role in the oil-saving measure. I will explain how hybrid system contribute to low fuel consumption. The left shows conventional engine, and the right shows Toyota hybrid system. Toyota hybrid vehicle can utilize engine stop during idling, recovery of braking energy, Atkinson cycle as engine efficiency improvement, and EV drive with optimization of engine use. So, in comparison to the conventional engine, the Toyota hybrid system can get lower fuel consumption. The core technologies of hybrid, such as battery, motor inverter, can be relatively easier applied to EV, PHEV, FCEV. At current stage, we have paid a lot of effort to improve reliabilities and cost down of the HEV core components. After getting more matured on technology, we can easily adapt this to EV, PHEV, FCEV. This shows hybrid vehicle product lineup. Since the first generation Prius was introduced in 1997, and we have improved the hybrid system and adapted for other models. This shows hybrid vehicle sales. We have achieved the sales of 4.4 million by the end of August this year in the world. We think it is the result that many customers accept our concept of hybrid vehicle in the world. We expect to be able to exceed 1 million in sales of hybrid vehicles over the year. This is an example of our activities that aim everybody feel hybrid vehicle familiar. One is the application of hybrid technology to motorsports, which I had been representative to the racing team. Last month, we won the championship at WEC Race, World Endurance Championship in Shanghai, and I was able to enter the winner's podium. Another is about developing of HEV in China. We accelerate domestic production of core component and development of application technology to the vehicles in order to be accepted for customer in China. We want to contribute to the environment and the society through the spread of hybrid from now on in China. Next, I explain the next generation technology. This slide shows characteristic of the alternative energy. There are electricity, hydrogen, biofuel, and natural gas as the alternative to oil. We analyzed them in the 4 viewpoints: well-to-wheel CO2, supply volume, cruising range, and dedicated infrastructure. All alternative fuels have positive and negative aspects. As automotive energy, it is impossible to decide one alternative. This is an image of future mobilities. Pure EV is suitable for relatively short driving use in personal and in public service with current battery technology. HEV and PHEV, which don't worry about charging, can be replaced with conventional vehicles. FCEV will be suitable for larger vehicles, such as buses and trucks first. We think EV and FCEV is going to expand gradually. In the meantime, HEV and PHEV will play a key role as fuel-saving technologies. At the same time, alternate fuel vehicles also should be promoted steadily. Next, I explain PHEV. Toyota considered PHEV is a practical approach to utilize the electric energy. It is based on Toyota's hybrid system with lithium-ion batteries, which made it possible to be charged from external outlet. Toyota's PHEV can be used as an EV when you use in short driving ranges, such as commuting or shopping. After using up all charged electricity power, the vehicle can be driven as a regular hybrid electric vehicle, which means you don't need to worry about how much you can travel or where the charging infrastructures are. This slide shows the PHEV oil saving effect by field test in Japan, in the United States, in France, and in China, including market model in Japan. Effect of fuel reduction is depend on the charging frequency. But the fuel reduction effect was from 50% to 60%, comparing with gasoline vehicles in the same class. In various countries, we confirmed the oil-saving effect of PHEV. When we design the mass production PHEV, it is necessary to consider the 4 key factors. These are oil reduction effect, charging time, sales value, and packaging, and determine the adequate capacity of battery for PHEV. We believe the current production type Prius PHEV realized a specification that could satisfy the conventional car users. Finally, I explain EV and FCEV. Electricity can be made from various primary energy, and it is relatively easy to obtain stable supply. Besides, EV have three advantages as shown on left: no driving emission, quiet running, and rechargeable with household outlet. On the other hand, on right, there are some disadvantages such as shorter driving range, high battery cost, long charging time, and need for quick charge infrastructures. So, with the current technology basis, we think that electric vehicle is suitable for short distance usage or constant route commuting. To spread electric vehicles widely, it is necessary to develop the next generation battery. This slide shows the potential of next generation battery. The horizontal axis is energy density, and the vertical axis is power output density. We have been researching solid-state batteries and lithium-air battery. We have improved output density of the new solid-state batteries 5 times larger than current level with new solid electrolyte. And we would like to enhance the capacity of these batteries to reach the commercialization level. Shown here are the characteristics of FCEV. Those are: hydrogen can be produced from various primary energy sources. FCEV is zero emissions, smooth and quiet operation, and over 500 kilometers of practical cruising range. The refueling time is about 3 minutes, and large power supplies capability for emergencies. That's 4 to 5 times larger than EV. We consider FCEV is important technology in future and have been developing to launch in 2015. For future society and people's smile in China, Toyota has been working on energy conservation and fuel diversification. Thank you very much.
Thank you, Mr. Yamashina. Thank you.